ChatGPT said, genetic regulation plays a significant role in how effectively autophagy operates, and emerging research shows that variations or mutations in key autophagy-related genes may directly influence an individual's susceptibility to obesity and metabolic disorders. Genes such as ATG5, Beclin-1, and others within the autophagy pathway encode proteins that coordinate the formation of autophagosomes, the core structures that engulf and recycle damaged cellular components. When these genes are fully functional, they support a dynamic process of cellular renewal and metabolic regulation. But when these genes are partially silenced, mutated, or functionally compromised, the efficiency of autophagy declines. Over time, this genetic vulnerability can lead to an impaired ability to manage lipid balance, clear damaged mitochondria, or respond appropriately to nutrient overload, setting the stage for fat accumulation and systemic metabolic stress. ATG5, for instance, is a gene critical for the elongation and closure of autophagosomes. Animal models with ATG5 deficiencies exhibit enlarged, dysfunctional fat cells and are more prone to insulin resistance and weight gain, even when their diets are controlled. Beclin-1, another essential autophagy gene, helps initiate the formation of autophagosomes and coordinates with other cellular stress responses. Reduced expression of Beclin-1 has been linked to disrupted mitochondrial quality control, lipid droplet accumulation, and heightened inflammatory signaling, all of which are factors known to drive obesity-related complications. When either of these genes is compromised, the body loses a key line of defense against energy imbalance and cellular stress, making it more difficult to prevent or reverse weight gain. What makes this connection between genetics and autophagy particularly significant is that it shifts the focus away from blaming lifestyle alone. For some individuals, obesity may not result purely from overeating or inactivity, but from an inherent cellular disadvantage, the inability to engage autophagy effectively even under ideal conditions. This understanding helps explain why some people struggle more with weight management despite sincere efforts, and why metabolic dysfunction can appear in individuals who are not necessarily obese by body mass index, but have poor cellular resilience. Genetic differences in autophagy efficiency may also influence how well someone responds to dietary changes, fasting, or exercise interventions that rely on autophagy activation for their beneficial effects. However, even in those with compromised autophagy genes, there is promising evidence that lifestyle can still modulate the expression and activity of the autophagy machinery. While the baseline capacity may be lower, interventions such as intermittent fasting, physical activity, and consumption of certain phytochemicals can increase the functional output of remaining autophagy pathways. In other words, the genetic risk is not necessarily destiny. It highlights a vulnerability that can be partially compensated for through targeted environmental and behavioral strategies. There is also increasing interest in pharmacological agents that might safely upregulate autophagy in individuals with genetic impairments, offering potential personalized therapies for those at higher metabolic risk. The deeper message here is one of complexity, but also of potential. Understanding that autophagy-related genes influence susceptibility to obesity allows for a more nuanced, compassionate view of metabolic health. It opens the door to personalized medicine strategies, where genetic screening could help identify those who may benefit most from early intervention or more aggressive autophagy support. It also reinforces the idea that metabolic health is rooted in cellular housekeeping, not just willpower or calorie counting. When the genes that control autophagy are working well, the body maintains a powerful internal mechanism to clean, repair, and adapt. When those genes are compromised, the same mechanisms falter, but they are not beyond repair. By focusing on supporting autophagy through thoughtful, sustainable strategies, nutritional timing, physical activity, stress reduction, and micronutrient support, it becomes possible to work with one's biology rather than against it. This approach doesn't eliminate genetic risk, but it can mitigate its consequences, offering hope for those predisposed to obesity due to inherited factors. In this way, the study of autophagy genetics not only deepens our understanding of obesity, but also strengthens the tools we have to combat it, from the level of DNA to the level of daily life.